Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank one bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But, to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the western Cascades. That's why if you look at the two regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the high Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
Guess what? A huge ocean might be hidden deep beneath us, about 250 to 400 miles down, and it's bigger than any ocean on Earth's surface. Scientists were listening to earthquakes deep within our planet and noticed how these shakes slowed down when passing through certain parts of the mantle. This suggested that water was there. Models and experiments led them to uncover the underground ocean. But this ocean isn't like the typical water you imagine. It's a lot crazier. The mantle is a thick layer between the Earth's crust and core. It consists of the upper mantle, the lower mantle, and a mysterious layer between them called the transition zone. In the upper layer, we can often find a fascinating material called olivine, which got its name from a pretty greenish color. Olivine doesn't care about high temperatures and thrives in lava comfortably. It not only thrives, but it even makes up 50% of the entire upper mantle. We can find this stuff on Earth thanks to volcanoes. When volcanoes spew their magma out, all the minerals in it make their way to the surface. As magma cools and solidifies, it forms igneous rocks, and the minerals start to crystallize. Olivine is one of the first minerals to crystallize, and since there's so much of it in magma, it forms lots of crystals. Sometimes they're small, but sometimes they grow large and become very noticeable. We collect these large gemstones and use them to make pretty accessories and for other purposes, such as casting metals. But as we dive deeper within the Earth, about 250 miles down, things get strange for olivine. We enter the mysterious transition zone. The pressures get way higher, and the temperatures rise significantly. Here, olivine transforms into beautiful rock called wadsleyite and ringwoodite. Just like with olivine, we sometimes find them thanks to volcanic activity. Both are blue-green with a beautiful glassy appearance. Unfortunately, they're exceedingly rare and small, so you can't make accessories out of them. They're usually studied in labs. But they can do something that olivine can't. Thanks to their structure, they can act like a sponge, soaking up water. Now, this doesn't mean that they're literally wet. Rather, wadsleyite and ringwoodite can store water components, hydrogen and oxygen, within their structure. Usually, up to about 3% of them are water particles. These two little guys play an immense role in our planet's geology. They influence how the Earth's mantle conducts electricity as well as its viscosity, or how well it flows. This affects mantle convection, plate tectonics, and even volcanic activity. Without these tiny crystals, our planet would be completely different. The world could be mostly underwater, with just a few mountaintops visible. They also help us better understand how water works in general. So the transition zone is special because it's hydrated. Here we come to the recent discovery, a massive underground water reservoir. Scientists try to understand how water behaves in this deep part of the Earth. They discovered that as water-rich ringwoodite moves even deeper into the Earth to the lower mantle, it can start to melt a bit. This means it can release a bit of water and then trap it somewhere underground instead of letting it move around freely. But this released water wouldn't really be in its liquid, solid, or gas forms. Instead, it would be chemically bound to the underground structures. So, it won't be an ocean in the traditional sense, but there might be a vast amount of water down there. This finding is super important because it changes the way we understand Earth's water cycle and resources. It turns out that water isn't just found on the surface, but also moves through hidden spaces deep inside the planet. Another fascinating thing we discovered about water is that it might exist in a mysterious fourth state of matter. Now, we're used to thinking of water in its three common states: solid, liquid, and gas. But under extreme pressure in tiny spaces, it can enter a mysterious fourth state known as tunneling. We discovered this strange behavior in the mineral called beryl. Within beryl, there are super small six-sided channels, just about 5 atoms across. Turns out these channels act like tiny cages that can trap individual water molecules, like wadsleyite and ringwoodite. In these conditions, the water molecules start showing behaviors that are closer not to classical physics, but to quantum physics. Quantum tunneling allows particles to exist in multiple places at once or pass through barriers they shouldn't be able to. Imagine a ball that somehow ends up on the other side of a hill without climbing over it. It just goes through the hill. Hydrogen atoms in burl are like tiny balls. Typically, each ball would sit in one specific spot. However, in the experiment, these hydrogen atoms didn't stay still. Instead, they were found simultaneously in multiple spots. Together, they formed a pattern that looked like two wavy rings. It's like water molecules got smeared around in a ring shape. This is a state of water that we've never seen before. It reshapes our understanding of how water behaves under certain conditions, and it has huge implications for biology. All these discoveries have everyone rethinking where Earth's water really comes from. Water is essential for life as we know it. About 71% of Earth is drenched in water, and humans are mostly water too. When we figure out how it appears in space and on planets, it will give us clues about how to better search for extraterrestrial life. One theory says that when Earth was forming, the materials that clumped together to make the planet already included water, or at least the ingredients to make it. Earth formed about 4.5 billion years ago. Our planet slowly emerged thanks to gravity from dust, gas, and rocks that surrounded our newborn sun. This material gradually came together to form the planets of our solar system. However, the young inner solar system was a scorching place, too hot for any liquid water to survive. It would have simply vaporized and escaped into space. But it's possible that water was trapped inside the rocks that initially formed Earth. Some of the Earth's original building block contained much more hydrogen than all our oceans combined. It would also explain how water molecules got so deep underground. Then, volcanic activity could have later released the water stored deep within, sending it into the atmosphere as vapor. This vapor would eventually cool down, condense, and fall as rain, filling the young Earth with lakes and seas. Another idea is that after Earth was formed, water was brought here by wet space visitors like comets and asteroids crashing into the planet. Long ago, the inner solar system was a wild and chaotic place, much like Brightside. When the outer planets rearranged their orbits, this caused a ripple effect, which we now call the Late Heavy Bombardment. It sent a flurry of icy space rocks crashing through the inner solar system, many of which collided with Earth. For a while, scientists thought that this event and comets were a primary source of Earth's water. But then, we learned that comets have a different chemical makeup from the water on Earth. Then we looked at the asteroids. Their water closely resembles the water in Earth's oceans. Some of the samples even contained organic materials. There's also a chance some random planet helped us out. About 4.5 billion years ago, a Mars-sized planet named Theia is thought to have collided with Earth. It was a violent encounter that melted part of Earth's mantle and led to the formation of the Moon. Perhaps Theia also brought some water with it. And finally, Earth could have generated its own water. Chemistry says that hydrogen could react with molten rock in vast magma oceans to produce seas and oceans. It's also possible that all these ideas are true, and Earth's water came from several sources. It complicates our research, but shows how dynamic water can be in space.
See this big spot under the water near the shore? It's a coral reef. It beckons you to swim closer. But be careful. If you get there, it could be the last swim of your life. Stay away from the reef. But why? Why are coral reefs so dangerous? Let's figure it out. First, make your guess about what a coral reef is. An underwater cliff? Rocks? A coastal landscape? Some spot where shells live? Close, but not true. In short, a coral reef is a living thing. What we see in shallow tropical waters are colonies of organisms called coral polyps. They are distant relatives of jellyfish and anemones with amazing superpowers. They can absorb calcium from the water. When they do this, they convert calcium into hard limestone rocks. These rocks, like building blocks, form solid coral reefs and settle on the seabed. But there are soft coral reefs that look like plants. They float freely with the currents, swing in different directions, and seem to pulsate under the water. They don't have solid coral blocks, but they can grow tree-like cores to maintain their position. Both hard and soft coral reefs are beautiful creatures, but at the same time, they are very dangerous. Many ships were wrecked when they hit shallow water, as the sharp edges of coral reefs ripped through their hulls. But what danger is there for someone swimming alone, who isn't going to hit the reef? You can just scuba dive and enjoy the beautiful views of coral polyps, but be prepared to encounter unexpected and unpleasant creatures. A coral reef is not just a living colony, it's a home for thousands of diverse marine creatures. And some of them can be very dangerous for humans. Like the blue-ringed octopus, for example. This is a tiny creature that you will definitely notice thanks to the bright spots on its body, but don't touch it with your hand, as it's one of the most venomous creatures on Earth. The amount of toxic venom carried by this octopus can harm 26 people, and these people are unlikely to survive this encounter. The poison works within a few minutes, and there's no antidote in the world. What makes it even more dangerous is that the octopus's sting is painless. You probably won't even know you've been stung until the first symptoms appear: body paralysis, respiratory problems, and cardiac arrest. But even if you don't notice the octopus and swim past, you'll probably notice the box jellyfish, whose tentacles can reach several feet in length. It looks like a creature from deep space, and you better not approach it. The box jellyfish is considered the world's most venomous creature. There are special cells in their tentacles that release a toxin called nematocysts. Over the past 100 years, roughly 70 people lost their lives after encountering these jellyfish. But most likely the number is much higher. We just don't know about all such cases. Unlike the painless sting of the blue-ringed octopus, the encounter with a box jellyfish hurts. Another dangerous inhabitant of coral reefs is a rock. Yes, take a look. It's just a rock that's part of the reef. But wait a minute, it seems to be moving. Don't touch it. It's incredibly venomous. By now, you've probably already realized that this is not a stone. This is the stonefish. And this sullen-looking guy is one of the most venomous fish on the planet. Do you see those little spikes along its spine? The fish raises them when it feels in danger. If the toxin covering these spikes enters your body, you have less than an hour to take the antidote. If you don't make it in time, better not dwell on the worst-case scenario. Do you still want to swim closer to the coral reef? If so, go ahead. There are other scary creatures there. This one, for example, doesn't pretend to be a rock or something harmless. It looks dangerous, and it is dangerous. It's the moray eel. These underwater snakes are not venomous, but meeting them can be unpleasant. They can bite quite painfully, but only if you disturb them in their burrows. Of course, you probably won't want to tease these creatures, but you might accidentally approach their burrow without knowing they live there and poke it with your finger. Once you do it, get ready for a payback strike. By the way, moray eels are poisonous because they eat toxic algae and fish. However, they can't use this poison against you unless you try to eat them. As you approach the coral reef, you may encounter a flying dagger. This is the needlefish, a thin, fast fish with a sharp nose and prickly needle-like teeth. It swims near the surface close to coral reefs at high speed and then jumps out of the water and flies at a speed of 37 miles per hour. Many people have reported getting seriously injured by this guy. This one looks like barbed wire shaped like a star. Hundreds of sharp needles cover the crown of thorns starfish's body, and you'd better not touch them. Each thorn on their body contains dangerous toxins that cause pain, nausea, swelling, and can even lead to anaphylactic shock. Coral reefs are not just a place for them to hang out, but also food. This starfish bulges out its stomach, covers the reef surface with it, and absorbs nutrients from it. It's like something straight out of a sci-fi horror movie. But don't think that corals are something scary and dangerous. In fact, coral reefs are some of the most useful things in the ocean. They even save people's lives. Do you know that lines of coral reefs cushion the impact of tsunamis and protect the shores from flooding? Some large reefs, like the Great Barrier Reef, are the boundary between the open sea and shallow waters. They stretch along the coast and form a protective wall that serves as a barrier against tsunamis and landslides. During a storm, rocky coral reefs disperse large waves and soften their impacts on the shore. But the coolest thing is that corals help your Instagram profile look better. What? Yes, that's right. Do you know these beautiful paradise-style photos when the water near the shore is blue and the sand on the beach is white? So sand gets this unique color thanks to corals. As you already know, coral bodies are made up of calcium carbonate. When waves and storms destroy corals, they wash out these calcium particles directly onto the shore. Besides corals, tiny bits of crushed seashells also end up there. Over time, layer by layer, they build up to form white sandy beaches. By the way, parrotfish are also involved in creating this beauty. These little fish feed on algae that stick to coral reefs, so they also consume pieces of coral along with their food. Then, when they're full, they release the coral particles, which eventually become the white sand. One such fish releases about 200 pounds of coral waste per year. So in a sense, this white sand appears because parrotfish go number 2. Coral reefs are ancient. The average reef grows at a rate of about 0.7 inches per year. And now look at their sizes. The Great Barrier Reef stretches for more than 1,430 miles, and it's been growing for 8,000 years. It's been here since people began to develop agriculture, domesticate animals, and build the first settlements. And some reefs are much, much older. That's why it's so important to preserve this unique natural wonder. And humans end up destroying it, often when ships accidentally crash into coral reefs. When this happens, it ruins the home for thousands of sea creatures. Ocean ecosystems get majorly impacted. But we also try to improve the situation. Coast guards protect the areas where coral reefs grow so that no vessel can approach them. These majestic creatures are a crucial part of nature, and this is another equally important reason why we should stay away from them.
Over 1,500 people lost their lives in this part of the ocean, so maybe it's a prudent idea to stay away from it. The spot where RMS Titanic sank remains dangerous. I mean, yeah, there are still huge icebergs out there, but there are even bigger threats lurking beneath the surface. Titanic is sitting about 12,500 feet underwater, nearly 400 miles southeast of Newfoundland. It's been down there for over 100 years. So, over time, the wreck's just been falling apart little by little. The infamous ship is rusting just like any iron or steel structure would be underwater. Chemically, when you mix iron, oxygen, and water, that combo sets off a reaction that creates iron oxide, and that's what leads to corrosion. So, steel plates, beams, all that stuff is getting weaker. Parts of the liner are caving in, like the ceiling in the captain's bathroom and a section of the railing that collapsed not too long ago. But in the case of Titanic, a lot of that corrosion is actually being caused by iron-eating bacteria. When the Titanic sank, it split into 2 big pieces, the bow and the stern, which landed nearly 2,000 feet apart on the ocean floor. And now both pieces are covered in this biofilm, a living blanket of bacteria, marine fungi, and all sorts of other microbes. Over time, microbes feeding on the ship's iron have created these things called rusticles, and they are actually speeding up the wreck's decay. Scientists say the stern is breaking down way faster than the bow, mostly because it took more damage when the ship sank. And now, thanks to all that bacterial activity, the stern could be deteriorating as much as 40 years ahead of the bow. So yeah, microbes have been thriving and flourishing down there. If you are a germaphobe, that probably sounds like a total nightmare. But honestly, it's not that bad. For one, they don't even look gross. These rusticles actually look kind of cool, like ice crystals or tiny diamonds clinging to the wreck. And don't worry, you are not in danger. As long as you keep a safe distance from the wreck, no direct contact, and definitely don't go poking around inside, there really is no risk. Speaking of getting dangerously close, we've got to mention the Titan submersible disaster. You know, the one that catastrophically imploded back in 2023 during a trip to the Titanic wreck. Sadly, all 5 people on board lost their lives. Even though this trip was sold as a tourist adventure, going that deep in the ocean is no joke. It's terrifying, cold, and dark. Sunlight gets absorbed by water and can't reach much farther than about 3,300 feet below the surface. Past that point, the ocean is in total darkness all the time. Titanic lies within a region known as the Midnight Zone for this very reason. The few brave people who have visited the wreck say the descent takes over 2 hours through complete darkness. Then, out of nowhere, the ocean floor just pops into view, lit up by the submersible's lights. The second big challenge is actually finding the wreck. At that depth, navigating is no easy task. When you reach the bottom, you really don't know exactly where you are. You're just kind of fumbling around in the dark, knowing that Titanic is somewhere down there, but you can't see it. However, detailed maps of the Titanic site, made from decades of high-res scans, really do help. As the wreck starts to come into view, they can use those maps to stay on track. Plus, sonar and sensors let the crew notice features and objects even if they're way beyond the sub's tiny light pool. For example, the Titan submersible had a sensor called the Doppler velocity log. This one sent out sound waves to measure how fast the sub is moving and how deep it is, based on its distance from the ocean floor. Still, passengers on previous trips to Titanic in this submersible have said how tough it is to find their way once they reach the ocean floor. And we can't forget about the pressure. The deeper you go in the ocean, the more pressure the water puts on everything. And the pressure is crazy high at the Titanic's wreck site. To put it into perspective, it is about 200 times the pressure inside a car tire. That's why submersibles need super thick walls to handle it. So yeah, the water around Titanic has creepy microbes, pitch-black darkness, and insane pressure. But there is one more thing happening down there, and that's unpredictable currents. You're familiar with them. I mean, when you swim in the sea, you can usually feel the currents pulling you from side to side. But the deep ocean has its own set of underwater currents too. They're not as strong as the ones you feel on the surface, but they can still move massive amounts of water around. These currents can be caused by things like wind, differences in water temperature and salt, and even strange storms down on the ocean floor called benthic storms. They can get intense and stir up the sea bottom. Now, like I mentioned earlier, the Titanic wreck is in 2 big pieces, the front and the back, and researchers have been checking out the seabed of the surrounding area. One part of the wreck is near this cold underwater current called the Western Boundary Undercurrent. It flows south and moves mud and sand along the ocean floor, creating ripples and patterns that show how strong or weak the current is. Most of the time, the currents there aren't very strong. They even found sand ripples near where all the Titanic debris landed, like furniture, coal, and just random stuff from the ship. And those ripples are showing a current flowing from east to west. But inside the main wreck site, things get a little wilder. The water flows more from northwest to southwest, probably because all the huge chunks of the ship are messing with the flow. Around the south side of Titanic's bow, the currents get unpredictable too. They keep switching directions, from northeast to northwest to even southwest. It's like the ocean's just doing its own thing down there. Experts think that, over time, all this shifting water is going to slowly bury Titanic under layers of mud and sand. Little by little, the wreck could just fade away and disappear beneath the ocean floor. Alright, now it's time to get to the obvious issue here: icebergs. Yep, they're still a problem for ships today. In 2023, around 380 icebergs flowed into the busy shipping routes between North America and Europe. That's a problem. You see, the bigger the iceberg, the easier it is to spot and avoid. Smaller ice is a lot harder to detect, though it's no less dangerous. And that's because the most dangerous part is underwater, where no one can see it. Think about the iceberg that sank Titanic. Passengers saw about 100 feet of it above the water, but it's believed that's only 16% of its total size. Experts say the rest, hidden beneath the waves and much larger than what's visible, could stretch down several hundred feet. Now, the good news is that, unlike Titanic's day, we have much more technology now to spot icebergs in time. Modern ships have radar and satellite imagery that can pick up icy threats hiding in the dark. Some vessels even use sonar and thermal imaging to see through fog, helping the crew to spot icebergs above the surface. GPS and AIS pick safer routes, and monitoring centers around the globe send out real-time alerts, like having a personal iceberg spotting assistant. So, yes, it is a massive upgrade from just relying on binoculars. You won't have to worry about icebergs on your next cruise vacation, even if it passes alongside Titanic's route. But just to be extra safe, try not to travel with anyone named Jack or Rose, and never play the violin while on board. Just saying. Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and is called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please.
Mars can be secretly messing up the depths of our oceans. The red planet is 140 million miles away from Earth, so we once thought that it couldn't have much of an impact on us. But that changed recently with the discovery of some kind of butterfly effect. What starts with a small gravitational pull in space ends up creating giant whirlpools down here. This suspicion began when scientists decided to explore almost 300 deep holes drilled in the ocean floor, which were made back in the 60s. Their goal was to understand the strength of deep ocean currents by analyzing sediments. Materials like sand or mud that accumulated at the bottom of the ocean over the last 65 million years. The bottom of the ocean has layers upon layers of sediments. When these layers show a continuous pattern, it means that the materials have been gradually layering over time without any sudden interruptions. In other words, deep currents were calm and stable. But the researchers also noticed a strange pattern. During specific time periods, they couldn't find any records of sedimentation, which means that something else was interrupting this process. The most likely reason for these gaps was the presence of intense currents at the bottom of the sea. Because they were so strong, they probably moved sediments from their original spots. But here's the weird part. All the gaps identified in the study occurred at intervals of exactly 2.4 million years. The data showed a total of 27 gaps. That can't just be a coincidence. So, the scientists realized they were not checking simple breaks in the sedimentation process, they were analyzing the presence of cycles. According to experts, the only plausible explanation for them lies in space and is probably the result of something known as the astronomical grand cycles. To understand this process, we first need to mention the Milankovitch cycles. They're named after the Serbian scientist who suggested a century ago that changes in the way Earth moves around the Sun and tilts on its axis can affect Earth's long-term climate. The thing is, the movements of Earth can be affected by many things, including other planets. Normally, our planet's orbit around the Sun isn't a perfect circle, but it's pretty close. However, from time to time, this path is directly affected by the gravitational pull of Jupiter and Saturn. So it's kind of like these two giant planets can pull our orbit, causing it to become more elliptical. Variations like this can affect the amount and distribution of sunlight, changing the climate here on Earth. According to the Milankovitch theory, Earth's climate patterns change in cycles of 405,000 years, 100,000 years, 41,000 years, and 23,000 years. And the theory is that these cycles might trigger the beginning and the end of glaciation periods, also known as ice ages. His theories were actually confirmed in the 70s by scientists who were also looking for evidence of these cycles in ocean floor sediments. Recent calculations have shown that besides the Milankovitch cycles, there are climate changes that follow much slower rhythms. They don't change every tens of thousands of years. Nope. We're talking about periods that stretch out over millions of years. And this is exactly what the astronomical grand cycles that I mentioned earlier are about. We know about such events basically because of evidence based on mathematics and computer modeling. But it is really hard to find any geological proof of the existence of these million-year astrological cycles, or any clue of how they affect Earth. That is, until now. Turns out, what scientists found at the bottom of the ocean could be just the proof we needed. And that's because the 2.4 million period lines up exactly with records of interactions between Earth and Mars. As the two planets chart their orbital paths, their gravitational fields interact in a process known as resonance. Yep, exactly like what happens with Jupiter and Saturn. From time to time, the gravitational forces of the red planet pull our orbit a bit closer to the Sun. And just like the shorter Milankovitch cycles, this grand cycle also affects our climate. In this case, by increasing the solar radiation that reaches Earth, making our planet warmer. To be honest, experts believe that this amount of extra solar radiation that Mars can somehow give us is not that big of a deal. I mean, it's not going to make our planet so hot that it will make us feel like we're stepping onto the sun. But this slight difference in climate can be enough to change some behaviors on Earth, such as ocean currents. Warmer climates tend to produce more frequent major storms, and that often produces sediment-stirring eddies, also described as giant whirlpools, which can reach the seafloor at the deepest parts of the ocean, known as the abyss. Finding those gaps in the deep ocean sediment record is really impressive because it's probably the strongest evidence we have of the astronomical grand cycles. As I mentioned at the beginning of the video, it's all like the butterfly effect. Every 2.4 million years, Mars's gravitational pull shifts Earth's path around the Sun, causing our climate to warm up. And when the planet is warmer, it can lead to the formation of large whirlpools, which end up turning the deep ocean waters upside down. And there's one more thing. The cycles found in the research also line up with already known periods of warmer climate throughout world history, like the famous Paleocene-Eocene thermal maximum. This event took place around 56 million years ago, when Earth was warmed by about 14 degrees Fahrenheit. Loads of theories have popped up trying to figure this out, like a glitch in Earth's orbit or maybe the passage of a comet. But with this new study, it looks like Mars could also be involved in this event. These new findings are pretty convincing and exciting, sure, but scientists still need to do more work to link these possible cycles of climate change with deep-sea currents. I mean, they did a good job of finding an explanation for the sediment gaps, but so far, it's just a suggestion. Their success is really important for the whole scientific community, though. After all, knowing when exactly these astronomical grand cycles happen and how they affect Earth can help us a lot, especially to differentiate when climate change happens due to a natural event and when it occurs due to human intervention. Studying these whirlpools can also provide scientists with crucial insight into how climate change affects ocean circulation. So, another reason why this finding is so crucial has to do with the potential collapse of the Atlantic meridional overturning circulation. In short, this is a system of ocean currents that circulates water within the Atlantic Ocean, being responsible for bringing warm water north and cold water south. This is what brings warmth to different parts of the globe and also carries nutrients necessary to sustain ocean life. However, there are some fears that this system might stop or become too slow anytime soon. If that happens, oxygen-rich surface waters would no longer mix with deeper waters. But the good thing is that this possible link between Mars and Earth gives a positive take on this situation by suggesting that in a warmer world, more intense deep ocean currents may prevent our seas from stagnating. But again, it's just a suggestion. The evidence is still thin. Some skeptical experts like to point out that although eddies have indeed become more active over the past few decades, satellite observations have shown that their currents aren't always able to reach the seafloor and maintain an effective water circulation. For now, all we know is that it's hard to say who is right. Only the following studies will tell.
Ooh, you're diving into the dark and icy waters of Antarctica. The airy blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well. Off the western coast of Australia and near New Zealand, they recorded similar but higher pitch signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduck, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping. reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet Upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's Oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's Oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes, and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn!